Alright, so in this video, I'm going to solve the problem 2 to the power of 22 minus 1. So, to solve this, what I'm first going to do is rewrite this as 2 to the power of 11 times 2 minus 1. Now, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So 2 to the power of 11 times 2 is equal to 2 to the power of 11 to the power of 2 minus 1. Now 1 is the same thing as 1 squared. So now I have 2 to the power of 11 to the power of 2 minus 1 squared. Now the reason I did that and rewrote 1 as 1 squared is because now I can use the property a squared minus b squared is equal to a plus b times a minus b. So just to clarify, a is 2 to the power of 11 and b is 1. So now I get 2 to the power of 11 plus 1 times 2 to the power of 11 minus 1. Now, what is 2 to the power of 11? Well, 2 to the power of 9 is 512. 2 to the power of 10 is going to be double of 2 to the power of 9, which is double of 512, which is 1024. So 2 to the power of 11 is double of 1024, which is 2048. So now I get 2048 plus 1 times 2048 minus 1. Now 2048 plus 1 is 2049, and 2048 minus 1 is 2047. So I get 2049 times 2047. And now, a simpler way of multiplying this, rather than the usual method of this way takes way too long. So a much easier route is to rewrite this as 2000 plus 49 times 2000 plus 47. Now from here, I can simply distribute. So I have 2000 times 2000, which is 2000 squared, plus 2000 times 47, plus 49 times 2000, plus 49 times 47. Now 2000 squared is going to be 4 million, plus 47 times 2000 is 94,000, plus 49 times 2000 is 98,000, and finally 49 times 47 is 2,303. So now, by adding all these up, I get 4,194,000, because 94,000 plus 98,000 is 194,000, and then I have to add in the 2,303, so now I get 303 at the end. Alright, so in this video, I'm going to solve the equation 3 to the power of x plus 3 to the power of x is equal to 12. So, my only variable in this equation is x, so that's the variable I'm going to be solving for. And now for my solution. So I have 3 to the power of x plus 3 to the power of x is equal to 12. And what I'm first going to do is factor out 3 to the power of x. So I get 3 to the power of x times 1 plus 1 is equal to 12. Now 1 plus 1 is 2, so I get 3 to the power of x times 2 is equal to 12. So from here, we want to isolate x. And to do that, we have to get rid of this times 2 by dividing both sides by 2. So now these two cancel out. And I'm left with 3 to the power of x is equal to 12 divided by 2, which is 6. So now I have basically another equation from this much larger equation. So this is much more simplified. I have 3 to the power of x is equal to 6. So to solve this, well, we know that x is going to be a decimal because 3 to the power of 1 is 3 and 3 to the power of 2 is 9. So x is going to be somewhere in between 1 and 2. So we want to find the exact value of x. So how are we going to do that? Well, I'm going to first start by taking the log on both sides. So I get log 3 to the power of x is equal to log 6. And from here, if I have something in the form log a to the power of b, I can move this exponent b to the front. So this turns into b times log a. So I have log 3 to the power of x, and I can move x to the front. So I get x times log 3 is equal to log 6. Now I'm going to divide both sides by log 3, because again, we want to isolate x. So by doing this, these two cancel out, and I get x is equal to log 6 over log 3. Now, what I'm going to do is rewrite log 6 as log of 3 times 2. So I have log 3 times 2 over log 3. And if I have something in the form log of a times b, this is equal to log a plus log b. So log of 3 times 2 is equal to log of 3 plus log of 2, and I have this over log of 3. So now this turns into log of 3 over log 3 plus log of 2 over log 3. And now these two cancel out, so I get x is equal to 1 plus log of 2 over log of 3. Now, log of 2 is equal to 0.301, and log of 3 is equal to 0.4771. So I get x is equal to 1 plus 0.301 over 0.4771. And 0.301 over 0.4771 is 0.6309. So I have x is equal to 1 plus 0.6309, which is equal to 1.6309. So this is my solution.